This is one of those questions that feels like it should work, but physics just says no. A lot of people have asked this. Could you actually change the length of the day if every single person on Earth jumped at the exact same time? Well, let's dig in. So the thinking here is pretty straightforward, right? The Earth spins to the east. So if all 8 billion of us push off in a total opposite direction, west, that should give the planet a tiny little nudge, speed up its rotation, and make the day just a hair shorter. But does our intuition actually line up with reality here? Okay, so let's get into it. But first, we have to lay down some ground rules for what jumping actually means in this scenario. For our purposes, it means all 8 billion of us are lined up right on the equator to get the most possible leverage. And then everyone jumps perfectly west at the exact same instant. And absolutely no cheating, like just flying west in a plane. Nope, we're doing this the hard way. So before we get to the chaos, let's just look at the normal math. The whole idea here is based on a really fundamental principle in physics, the conservation of angular momentum. You've seen it with an ice skater, right? They spin faster when they pull their arms in. Same idea. But unfortunately for our big jump, this is where things get, well, kind of disappointing. Now, what's really wild about this is the sheer mind-boggling difference in scale. I mean, look at this. The combined mass of every single human on the planet is about 500 billion kilograms. That sounds massive, right? But then you put it next to Earth's mass, which is almost 6 septillion kilograms. That's a 6 with 24 zeros after it. In the grand scheme of things, all of humanity put together is barely a rounding error. So when you actually run the numbers on this, what do you get? Our perfectly coordinated planet-wide jump would shorten the day by a grand total of negative 0.1 nanoseconds. That's less time than it takes a beam of light to travel 1 foot. All that coordination, all that effort, for an effect so ridiculously small we literally wouldn't be able to measure it. And there's a whole other issue here, what we can call the Jell-O problem. We tend to think of our global civilization as this big, robust thing. But if you try to pull off a stunt of this magnitude, it's actually more like wobbly Jell-O. I mean, just the logistics of moving 8 billion people to the equator, the food, the water, the housing, our society would completely collapse long before anyone even got a chance to bend their knees. But hey, the question was never, is this a good idea? The question was, could you do it? And physics is great because you can always find a bigger number, even when common sense is screaming at you to just stop. So let's stop being sensible. All right, so let's just throw that disappointing reality out the window and figure out what it would actually take to hit our goal, no matter what the cost. Let's forget about nanoseconds. That's useless. Let's reframe the goal to something we could actually feel. What would it take to knock 1 full second off the Earth's rotation? A simple jump clearly isn't going to cut it. We need to apply a whole lot more power. To actually make this happen, we need a totally new plan. First, just forget jumping. That's child's play. We are going to gather the entire mass of humanity into a single object, a projectile. Then we launch that projectile westward at a pretty significant chunk of the speed of light. Let's call it 10%. Now things start to get interesting. This chart really puts into perspective the monstrous amount of energy we are now dealing with. The energy from our little jump is so small you can't even see it. The largest nuclear bomb ever detonated? It's just a blip. The energy to launch humanity's entire mass at 10% the speed of light? Well, it's an amount so unbelievably vast, it literally breaks the chart. It just dwarfs anything humanity has ever created. At these kinds of energy levels, you wouldn't die in any way we normally think about it. The forces involved are so extreme that concepts like biology and life just stop applying. You would simply cease to be a collection of cells and instead become a problem for physics to solve. The effect of this launch would be instantaneous and completely catastrophic. In the very first millisecond, the friction would ignite the atmosphere into a glowing plasma. By the 5-millisecond mark, the oceans are already boiling away into space, and by 10 milliseconds, a global shockwave is wrapping around the planet, vaporizing the crust. So, we've done it. We successfully shortened the day by 1 second, at the very minor cost of annihilating all life and turning the planet into a molten ball of slag. But believe it or not, the problems don't stop there. Now we have to deal with the paperwork. You see, setting aside the trivial matter of the total destruction of the planet, this little project of ours would put you in direct violation of international law.
The 1967 Outer Space Treaty specifically forbids the weaponization of celestial bodies, and turning the collective mass of humanity into a relativistic projectile is, let's be honest, a pretty clear violation of that.
This is a bad idea. A truly horrible idea, actually. I feel like I really shouldn't have to clarify that, but just in case anyone is getting any bright ideas, do not gather everyone at the equator and launch them into space. So, to give a simple answer to that original question, no, this won't work. Not the nice, sensible way, and certainly not the apocalyptic, relativistic projectile way. And here's the crucial takeaway. It fails not because the physics is wrong, but because our human-scale intuition is just fundamentally mismatched with planetary-scale reality. The rules of physics are the same, but the scale changes everything. Once you really get that, you'll start noticing this exact same mistake in all sorts of science myths and life hacks, and that's exactly the kind of thing we love to explore here.